After we learned the right triangle trigonometry, I'm going to expand beyond a triangle, because when we have a triangle, the angles are always between 0 and 90 degrees. So if you want to show that in the xy coordinate plane, it always stays in the first quadrant. Okay, so right now I'm going to introduce a new concept. It's called a unit circle. By doing that, we're going to expand our knowledge from triangle, right triangle, to all the angles. And also, we only focused on sine and cosine. So that's the only thing that we would care the most right at this moment. Now, think about this right triangle. This is the angle A. Okay, and here's a 90-degree. Here's a little a, and this is a B, and this is a B, and here's a C. And that's what we learned in the previous class. And if I want to do sine A, that will be the little a over little c, right? If I can expand this into twice as big, so is that here going to be 2a, here is going to be 2c, and what about the sine A? Sine A will be 2a over 2c, which is the same as a over c. Now you see that this angle and the sine function of it has nothing to do with the length of those sides. Okay, it's just the angle itself. Therefore, I said, well, I might want to standardize that by shrinking the long side back to 1. So if you have this is 1, here's A, and then what is this side? That should be A over C, but this C is 1, that shrink back to 1, so divided by C. So here is going to be A over C, isn't it? So sine A is going to be A over C divided by 1. Okay, now keep this in mind. What I'm going to do is I'm going to draw a xy coordinate plane, and I draw a circle with the radius, with the radius of 1. Not very pretty one, but here is 1, and here's 1, and that's negative 1, 0, and here is 0, negative 1, and this is 1, 0, and here it's a 0, 1. That's a y-axis, here's x-axis, okay? Now, if I have this unit circle, it's like a standard pie. And then if I draw this A, angle A, what is going to be the sine A? What is going to be the cosine A? Now, if you draw a line down here, here's a 90-degree, right? Goes vertical. This is the radius. This is 1. Did you notice that the length of this side is the same as the sine A? And the length of this side is going to be cosine A. Therefore, it's going to be cosine A, sine A. That is the coordinate of this point. All right? Now you keep this in mind. We have a cosine A, we have sine A. Here's a cosine, here's a sine. Okay, I want you to think about this. Draw a unit circle, okay? And I would ask you to keep your eye. That's your eye. Okay. All right. I want you to keep your eye looking this way. Now, if here's an angle A, you see how much this point lift up from this x-axis. Did you see that? Because you see this way. What do you see? You see, oh, it goes up by this much. That is the sine A. Okay. Now I want you to know that the sine just talk about how much you're away from this x-axis. Now the other way around, if you have a circle, and I ask you to look at down. If you look down, okay, so here's the angle A. if you look down here, you don't see how much it lifts up from the x-axis, but you see how far it is away from the y-axis, which is this part, right? If you look down or reflect this point down to, or reflect this line down to the x-axis, what do you got? You got a cosine A. Okay? All right. Now, the other way I want you to see here. If you have an angle, and here is 1, and this is xy, which means this is x, this is y, here is a. Now what do you get? You get a sine A. Sine A is the y over 1, which is the y. Cosine A is x over 1, which is the x. So on the unit circle, for any angle you have, and then you just find where that angle, this like intercept with the circle, and if you can find the coordinate here, and then you can know what angle is that. This is the basic concept about that, okay? Now, what I would like to see is this. Remember, you look at this way. Okay, so let me talk about the sine A. Sine is how much it goes up or down, right? Okay, so in the first quadrant, this sine, the sine of sine A, okay, for the first quadrant is positive because it goes up. And for the second quadrant, it's also positive, isn't it? And for the third quadrant, it starts below the x-axis, so that sine starts getting negative. And here is also negative. This is the sine of a sine. And then what about the sine of cosine? Remember, you're looking down, right? Okay, so did you see that? This unit circle. Cosine, we talk about how much it reflected down to the x-axis. So far from here to here, all the x, they are positive. And from here to here, did you see that goes to the left of this y-axis, so it becomes negative? And here, it's still negative. And when you goes here, so it goes to the right of the y-axis, so the cosine is positive. Now I want you to look at this. If an angle stays at, if the angle's terminal line, right, is in the first quadrant, you get a positive sine, positive cosine. Second quadrant, you get a positive sine, negative cosine. Third quadrant, negative, negative, negative sine, negative cosine. And the last one, the fourth quadrant, you get a negative sine and a positive cosine. Sounds interesting, isn't it? All right. Now, what we're doing right now is like one full cycle, right? So I'm going to introduce you another concept. It's called reference angle. Every time we talk about the reference angle, we always talk something from 0 to 90 degrees. 0 to 90 degrees. That's it. So for example, if you have this is 10 degree, and the reference angle is also 10 degrees. It's the same. If it's from here to here, if that is 110 degrees, then this is the terminal line, and we only talk about the reference angle is the angle between the terminal line and the x-axis. It has to be between 0 and 90. So this is going to be, this angle is going to be the reference angle for 110. Make sense? Okay, so that's this angle. All right, now this 110, so what is this angle? Reference angle will be 70 because that is 180 subtract 110, because we only look at this little part. All right. Now, what about a 200 degree? 200 degree, which is from here to here, is 180, and then you go more than that by 20. So the reference angle is just 20 degree, because here's 180 and 20. So you draw the line, and you find the angle between this line and the axis. So that is 20 degree. Okay. So what about 730 degree? Not 730, 700 degree. Sorry, let me change that because it doesn't look like that. So let's get a 690 degree. 690 degree, because you start from here. So this is a 360, and then 690 subtracted by 360, you get a 330. So 90, 180, 270, and then you need to go 60 more. So here it's a 60 degree, and here is the 30 degree. So that's your reference angle. So for 690 degree, the reference angle is a 30 degree. Okay, so I want you to think about this and remember the reference degree is always between 0 and 90, which is an acute angle, and it's the terminal line, is the angle formed by the terminal line and the x-axis. Okay. Why we want to do that? Okay, I want you to go back to think about. See, I'm drawing this a lot, right? The unit circle, I draw this. Oh, I'm so sorry. Okay, let's see, 150 degree. If here is 150 degree, the reference angle is going to be 30 degree, isn't it? Right? And for the 30 degree angle, this is the unit circle, and this is 1. Do you remember the special sine cosine for 30 degree? Sine 30 degree equals 1/2. If you don't remember, please go back to my previous class, and cosine 30 degree is going to be √3/2. Now keep in mind this 30, this reference angles, sine cosine, both are positive. However, 150 degree, this in the second quadrant, so sine 150 degree should be positive, isn't it? Because it's above the x-axis. So we just take the positive value of this trigonometric function of the reference angle. What about a cosine? 150 degree. Cosine, because that's to the left of the y-axis, is negative, and then we take √3/2. Okay. Now, you see that we combine a lot of information here together. I'm sorry, this is ugly, but this is the unit circle, and also we learned how to do the reference angle. And you get the reference angle. Remember that we have the sine, cosine, and also tangent for some special angle, like a 30 degree, 45 degree, and 90 and 60 degree. And you can use that. You can do a lot of things. Okay. Now, the next thing I want you to know is this. For whatever value of measurement of that angle, okay, and keep in mind this is the sine x, here's the angle x, and here's the cosine x, because here's unit circle, so that is 1. And then we have, I'm so sorry, my graph is not very pretty. Okay. So we have the Pythagorean theory, which is a squared plus b squared equals c squared. So I have sine square x, which is sine x squared. It's the same thing. It's just little different expression. Plus cosine square x equals 1, right? This is square plus this is square equals 1. Remember this. This is the super important formula in trigonometric function. And then we have a sine square plus cosine equals 1. It doesn't matter how big value or how big that angle x is. Okay. even you have this, you get a positive sine, negative cosine, doesn't matter because the cosine is also square it becomes positive. So this is always true. This is always true. And it doesn't matter what x is. Okay, I just want you to keep in mind of this. All right. Let me ask you one example. Here is 120 degree. All right. Now, you find sine 120 degree and a cosine 120 degree. If here's 120 degree, the reference angle should be 60 degree. And then so 60 degree is somewhere like that. Okay, so 60 degree, here's a 60 degree. And do you remember the portion is 1, 2, root 3? Or divided by 2, here's going to be root 2, right? 1, 2, root 3. Or you go sine of 60 should be 1 over this, or should be 2 over root 3. It doesn't matter whatever value you want. So you have the sine 60, which is root 3 over 2. Okay. And then so that's, did I 1 let me do that again. Okay. So here's a 1, here's a 2, here's root 3. I did that wrong. So here should be a 1, here's 1/2, and here's root 3. So that's right. That's a 60. That's a sine 60. And then for 120, the sine is also positive, but the cosine is negative. So that should be negative. And the reference angle for this 120 is a 60. And the cosine should be just 1/2 over 1. So that's going to be negative. Not only the value, you use the reference angle to find the value of a sine and cosine, and also you use what we learned for the first, second, third quadrant sine of sine and cosine to add the sine to the value. Then you can get this answer. Okay, it's pretty short for this section because we don't deal with a tangent. We only deal with the sine and cosine at this moment. So that's about it.